Problem set 38. This will be part one. I'm going to do the first two parts of the lesson, but the third one I'm going to have to make another video because it's a little bit more involved. More distance problems for you guys. It's great. This is fundamental counting principles and permutations. It's not too difficult, okay? They say let's say you have three letters A, B, C. How many different ways could you put them in order without repeating the same, without repeating a letter? So it's always going to be an A, a B, and a C. An A, a B, and a C, an A, a B, and a C, an A, a B, and a C, etc., etc. Well, the most ways you could do it is, this is the way, you got a box here. There's only three letters. You could have an A, a B, or a C here. So there's three letters that could be there. Without repeating, okay, if you've used one of the letters, say you use A, then for this second box, there's only a B or a C left. There's only two options. Okay, now let's say you used an A and then a B. Then you've used two of the three letters. Now there's only one option left, C. So you multiply these, 3 times 2 times 1. There are 6 different possibilities without repeating. Okay? ABC, ACB, BAC, BCA, CAB, CBA. So you can see that when you do a permutation, it's the number of options for the first box, and then number of options for the second box, number of options for the third box. This is without repetition. So 3 times 2 times 1 is 6. Now, what if there was repetition? Holy underwear. There are a lot more. You could do AAA, AAB, AAC. I'm not going to go through all these. But with repetition, okay, you can use an A, a B, or a C there. You can use an A, a B, or a C there. An A, a B, or a C there, right? So that's 3 times 3 times 3, which is 27 different options. Okay? And you can see that right there. Right? 3 times 3 times 3. So, how about this right here? 3, 5, 7, and 8. How many different ways can the numbers 3, 5, 7, and 8 be arranged in order if no repetition were available? Well, you have 4 options for the first box, 3 options for the second box, 2 options for the third box, and 1 option for the fourth box. So 4 times 3 times 2 times 1. 24 ways. Now, how many 4-letter signs can be made from the letters in the word equal? 4-letter signs. That means that there are 4 boxes possible, but the letter equal has 5 letters. If repetition is permitted, then you can use an E, a Q, a U, an A, or an L there. You're allowed to repeat, so same options there, same options there, same options there. 5 times 5 times 5 times 5, 625 options. Now, this is where, like, tests, this is the math for tests. A multiple choice test has 8 questions. If you don't know anything, literally nothing, and you try and guess the answers, there are 4 possible choices to each question. How many different sets of answers are possible? Now, this is why it's really difficult to just guess on a test. This is only 8 questions. There's 4 per question. So 8 boxes, 4 options for each box. You multiply that out, 4 times 4, there's over 65,000 different combinations. So if you're just guessing, you're not going to do well on that test, you know? So you got to study up. Does that make sense? There's 4 options for 8 different questions, so you multiply it out 8 times. Now, how many three-letter signs can be made from the words numeral if no repetition is permitted? Numeral has 7 letters, so it's going to be 7 times 6 times 5, 210. All right, so I think